Hello everyone, today we will learn the stiffness matrix method. So we will see one example, that is using stiffness matrix method, analyze the beam and draw the BMD. So given figure indicates the continuous beam. In this you can see there are three spans AB, BC and CD. On span AB and BC there are two concentrated load are acting at the center, that is 110 kilonewton and 50 kilonewtons respectively. And on span CD, intensity of UDL of 20 kN per meter is acting. The span for AB is 4 meter, BC is 4 meter and CD is 4 meter. Now the solution for this is, step number 1, we have to find the degree of kinematic indeterminacy, that is dk. So degree of kinematic indeterminacy means the unknown displacement. By observing this particular figure, you can see at point A there is a fixed support, at point B there is a hinge support, C there is a hinge support, and at D there is a fixed support. So at point A the slope as well as deflection, that is 0, that is displacement, vertical displacement is 0, as well as slope, that is theta A, is 0. Now at support B and at support C, the theta B and theta C, these are the unknown displacement, but the vertical deflection at B and C is 0. At point D you can see again there is a fixed support, so theta, that is slope, as well as the deflection, that is the vertical displacement, is 0 at point D. So there are only two unknown displacement, that is at point B, at support B and at support C. That is unknown displacement are dk is equal to 2, that is theta B and theta C. And known displacement are theta A is equal to 0 and theta D is equal to 0, because at A and D there is a fixed support. Now step number 2 is find fixed moments. For span AB, you can see span AB, the concentrated load of 110 kN is acting at center. We have to find out MAB and MBA. So MAB, if the concentrated load is acting, the formula is WL upon 8. Negative sign because of the anticlockwise movement. So minus W is 110, concentrated load is 110 kN, into 4, that is span, divided by 8, so you will get minus 55 kN meter. Now for MBA, that is WL upon 8, positive sign because of the clockwise movement, so W is 110 into span is 4 divided by 8, so you will get 55 kN meter. Now for span BC, you can see the span BC, the concentrated load is acting 50 kN at the center. So we have to find out MBC and MCB. So MBC is equal to, if the concentrated load is acting, the formula is plus WL upon 8. So WL upon 8, negative sign because the movement is anti-clockwise. So 50 into 4 divided by 8, so you will get minus 25 kN meter. And MCB is equal to the plus WL upon 8, plus because of the clockwise movement, MCB is clockwise, so W is concentrated load, that is 50 into 4 span divided by 8, you will get 25 kN meter. Now you can see for span CD, on span CD UDL is acting, having intensity 20 kN per meter, and the span for CD is 4 meter. You can see we have to calculate MCD and MDC. So if the UDL is acting on span, in that case the formula to find out the fixed end moment is, that is MCD is equal to minus WL square upon 12. So 20 is your intensity of UDL into span is 4 square divided by 12, so you will get, that is minus 26.66 kN meter. Negative sign indicates the movement is anticlockwise in nature. Now MDC, that is plus WL square upon 12, that is by putting the values you will get plus 26.66 kN meter. So the positive sign indicates the MDC is clockwise in nature. Now step number 3 is assign coordinates at dk. So you can see here the degree of kinematic indeterminacy was 2, that is unknown displacement were theta B and theta C. So I will assign the coordinates for theta b as a 1 and for theta c as a 2. So there are two coordinates 1 and 2 assigned for the degree of kinematic indeterminacy for unknown displacement for theta b and theta c, that are 1 and 2. Now we will see step number 4, that is calculation of elements or coefficient of stiffness matrix. In this we will first learn the concept related to that will not include in the solution. So first is remove all the loads on the beam and apply unit rotation at the coordinates one at a time. That is, you can see this concept. First case is if unit rotation is at A, if I have applied unit rotation at A, in that case the value at far end, that is at hinge end, will be 2ei upon L, and at A the value will be 4ei upon L. Both the rotation will be clockwise. Okay. In second case, you can see if unit rotation is at B and far end is fixed, in that case you can see if unit rotation is at B, the value will be 4ei upon L at B, and at far end is fixed, the value will be 0. Now in third case, you can see if unit rotation is at C, that is at intermediate support, the value will be at intermediate support will be 4ei upon L. Both the rotation will be clockwise, and at the far end, at A and at C, the value will be 2ei upon L. Here also you can see the value is 2ei upon L, but all the rotation will be clockwise in nature. And this is the deformed shape of the beam, that is AB and AC and CB. We have already seen in the previous concept, that is if unit rotation is at intermediate support, in that case if the far end is hinged, the value is 2ei upon L, at intermediate support the value is 4ei upon L, and if the far end is fixed, the value is 0. Now we have to apply unit rotation at B. We have to consider the nearby span of the coordinate B, that is BA and BC. So at point B, the value is 4ei upon L, and if the far end is fixed, the value is 0, and if the far end is hinged, the value is 2ei upon L. Now if applying unit rotation at C, we have to consider the nearby span of the coordinate C, that is CB and CD. So if unit rotation is applied at C, the value is 4ei upon L. If far end is fixed, the value is 0, and if far end is hinged, the value is 2ei upon L. Now step number 5 is determine the stiffness matrix K. You must remember this, if 4 supports, that is you can see here the 4 supports are there, hence the matrix will consist of 4 columns, and 2 coordinates, that is 2 unknown displacements are there. In that case we have to consider 2 rows. But the net matrix will be 2 by 2 matrix, discarding the rows and columns of 0 element. You can see here the 4 supports are there, hence the 4 column will be exist, and 2 coordinates are there, hence 2 rows will be present. But the net matrix, after deleting the rows and columns of 0 element, your net K matrix will be 2 by 2 matrix. Now we have to find out the stiffness coefficient, that is K11. That is K11 means the first coordinate effect on first point. Now you can see here, this is the first coordinate, and these are the points 1, 2, 3, 4. That is first coordinate effect on first point, it is 0. So first coordinate effect on first point is 0. Now again you can see here K12, that is first coordinate effect on second point. You can see here first coordinate effect on second point. So the effect is 4ei upon L and 4ei upon L. Both are clockwise, hence the addition will be there, 4ei upon L plus 4ei upon L. Now you can see here 4ei upon L plus 4ei upon L, but the span for both the BA as well as for BC, the span is 4 meter and 4 meter. So that is 4ei upon 4 and 4ei upon 4. So you will get K12 is equal to, after simplifying, 2ei. Now K13, that is first coordinate effect on third point. Now you can see here first coordinate effect on third point, it is 2ei upon L. So you can see the value is 2ei upon L. What the span for that is, L is the span of BC. Okay, it is 4 meter. So the value is, after simplifying, that will be 0.5 ei. Next is K14, the first coordinate effect on fourth point, that will be 0. You can see here the first coordinate effect on fourth point, it is 0. Okay, so your K14 will be 0. Now next is K21, second coordinate effect on first point. Now you can see here when unit rotation was applied at second coordinate, this figure we have to consider. So second coordinate effect on first point, it is 0. Now K21 is 0. Now K22, second coordinate effect on second point. So second coordinate effect on second point, it is 2ei upon L. Span will be BC, that is 2ei upon 4. Span of BC is 4 meter. So 2ei upon L, that is 2 upon 4 ei. So you will get 0.5 ei. K23 is second coordinate effect on third point. So you will see here second coordinate effect on third point. It is, here is 4ei upon L, 4ei upon L, that is 8ei upon L. L will be different for BC as well as for CD, but here the L is 4 meter for each span. So 4ei upon 4 plus 4ei upon 4 for this span. So you will get, the value will be 8ei upon 4. So the value will be, K23 will be 2ei. Now K24, that is second coordinate effect on fourth point. So you can see here second coordinate effect on fourth point, it is 0. So the value will be, K24 will be 0. So our stiffness matrix will be, you can see here our stiffness matrix will be 0 in first row, 0, 2.50, second row it will be 0.520. So we have to discard the elements which are having the 0 value, that is we have to discard the row and column which are having 0 value. So after discarding, our net matrix will be 2 by 2 matrix, that is 2.5.52. Now step number 6 is we have to calculate the P forces, P1 and P2. That is P1 means summation of moments, friction moments at coordinate 1, and P2 means summation of friction moment at coordinate 2. So you can see here, that is our first coordinate was theta B, this was the first coordinate, and theta C was the second coordinate. So we have to find the P1 and P2. It is P1 is summation of friction moment at first coordinate, that is MBA dash and MBC dash, summation of these two, and P2 means summation of friction moment at second coordinate, that is at C, that is MCB dash plus MCD dash. Now you can see P1 is MBA dash plus MBC dash and P2 is MCB dash plus MCD dash. So MBA dash and MBC dash, the values already we have calculated in step number 1. So you can see here MBA dash is plus 55 kilonewton meter and MBC dash is minus 25 kilonewton meter. So by putting the values, you will get 55 minus 25, you will get 30 kilonewton meter, and for P2 MCB dash plus MCD dash, by putting the values you will get 25 minus 26.66, that is 1.66 kilonewton meter. So we have to put the values P1 and P2, that will be 30 and minus 1.66. Okay, now one note you must remember, opposite the sign of the P matrix before putting the value in the equation. Now the formula for solving the equation is K into theta is equal to P. So by putting the values of K and theta is unknown displacement, theta B and theta C, and we have to opposite the sign of the P matrix, that is minus 30 and plus 1.66. Initially the values were 30 and minus 1.66, but here I have changed the signs, that is minus 30 and 1.66, that is positive. So solving this matrix equation number A, so the equation will be in this form, that is 2 theta B plus 0.5 theta C into EI is equal to minus 30, and 0.5 theta B plus 2 theta C EI is equal to 1.66. By solving this with the calci, you will get theta B is equal to minus 16.22 divided by EI, and theta C is equal to 4.88 divided by EI. After finding the value of theta B and theta C, next step is step number 7, that is slope deflection equation. Write the slope deflection equation. So we have to put the value of theta B and theta C in this equation to get the final end moment. Now you can see here the slope deflection equation for AB is m dash AB plus 2EI upon L in bracket 2 theta A plus theta B. So we have to put the value of theta B and theta A and m dash AB. M dash AB we have already calculated the fixed end moment. So by putting the values, minus 55 plus 2EI upon L was 4 for span AB, and at theta A it is fixed support, hence the value of theta A is 0, and theta B already we have calculated, that value is minus 16.22 EI divided by EI. So you will get MAB, final end moment at AB will be minus 63.11 kilonewton meter. Simultaneously we have calculated all the values MBA, MBC, MCB, MCD, MDC. So these are the final values that we have calculated, that is final end moment. Step number 8 is draw BMD. You can see this continuous beam. The final end moments are shown here, that is 63.11, 38.78, 21.77 and 29.1. So fixed end moment diagram, you can see here the fixed end moment diagram, and that is free BMD. The formula for if the concentrated load is acting on span AB, the formula is WL by 4. On BC, the concentrated load is acting, the formula is WL by 4. And if the UDL is acting on span CD, the formula is WL square upon 8 to find out the free BMD. Okay, so the values are 110 kilonewton meter, 50 kilonewton meter and 40 kilonewton meter. So the BMD by superposition will be like this. So thank you for watching this video. Please like, share and subscribe this video. Thank you.